Hi guys, welcome to lesson 8.2, multiplying and factoring. Our objectives for today, we have two of them. The first is I can multiply a monomial by a polynomial. And the second one is that I can factor a monomial from a polynomial. Now, our essential understanding is basically that we can use the distributive property to multiply a monomial by a polynomial. So problem number one is just going to be multiplying a monomial and a trinomial. So we have 5n that's being distributed to 3n cubed minus n squared plus 8. So we use our rainbows and we're going to distribute to each of our terms. So 5n times 3n cubed is going to be 15n to the fourth. So we're using our multiplying rules of exponents. 5n times negative n squared is going to be minus 5n cubed. And 5n times 8 is 40n. Okay. Letter B, we're distributing negative 2x squared to each of our three terms. So negative 3 times 4 is going to be negative 12x to the fourth. Negative 3x squared times negative 2x is minus 6x cubed. And negative 3x squared times 3 is minus 9x squared. Letter C, we have negative 2x being distributed to y squared, 4y, and 3. So we have negative 2xy squared plus 8xy minus 6x. Okay? I want you guys to try letters D, E, and F on your own, and then we're going to go over them. So the first term, we are multiplying x squared times 3x cubed, so that'll be 3x to the fifth. X squared times negative 2x squared is minus 2x to the fourth. And x squared times 8 is 8x squared. Squared. Okay. All right. Letter E. We are distributing z cubed to each of our terms. So z cubed times 4z cubed is 4z to the sixth. Z cubed times negative 3z squared is minus 3z to the fifth. And z cubed times negative 2z is minus 2z to the fourth. Okay. Our last problem in this section, m to the fourth times n to the fourth is m4 n4 plus, if we multiply it times 2n squared, it'll be 2m to the fourth n squared and minus 4m to the fourth. All right. Now, problems 2 and 3, we're going to do at the same time. Problem 2 is finding what our greatest common factor is in each of our trinomials, and problem 3 is to factor that out and simplify. So the first thing I'm going to do is I'm going to list all of the factors of each of my terms. So the first term is 3x to the fourth. So I have a 3, 1, 2, 3, 4 x's. My second term is negative 9x squared. Well, negative 9 I can break into negative 3 times 3, and there's 2 x's. And negative 12, I can break that into a negative 4 and 3, and we have 1x. Now, what I want to do is I'm going to look and see what do I have that is overlapping and a common in all three of my terms. Well, I have a 3 here, a 3 here, and a 3 here. That's one common factor. So I'm going to write that down below here. And I have 1x in all three of them. So I'm going to write that x. Those are my two common factors. Is there anything else that appears in all three lines? No, there's not. So now we put parentheses, and now we have to just combine back what was left. So my first term was 3 x's, so that's going to be x to the third power. My second term, I have a negative 3 and an x left, so minus 3x. My third term just has a negative 4 left, so minus 4. Now, if we were to distribute and we go backwards, we can check our work here. 3x times x cubed is going to be 3x to the fourth. That's what we have. 3x times negative 3x is negative 9x squared, which is what we have. And 3x times negative 4 is minus 12x, which is what we had. So, letter B, we're going to list out our factors. So 6x cubed, that's going to be a 2 times a 3 times x, x, x. Okay. 12x squared, well, that's made up of 4 times 3, and 4 can be broken into 2 and 2. So it's 2 times 3, and there are 2 x's. My third term, 18x, we've got 2 times 3 times 3 times x. So now we need to identify what are my things, or what numbers and what letters do I have that are common in all three of our factors. Well, I have a 2 in all three of them, and it looks like I have an x in all three, and there's a 3 in all three. So down below, what's 2 times 3? That's 6x. And what am I left with? My first term has 2 x's, so that's x squared, plus 2x plus 3. Because those are my terms, or my items that are left unhighlighted. Okay. Now, as you get better at this, you're not necessarily going to have to list out every single term like we have. All right. Letter C, 8x squared y to the third. Well, 8 is made up of 2 times 2 times 2, x, x, y, y, y. Okay? My second term is negative 4x squared y. So I have a negative 2, a 2, an x, and a y. My last term is 2 times 3 times x times y. So again, I'm going to look for what do I have that's overlapping. Well, I have a 2 in each of my terms. I have 2's up here, 2 there, but I have a 3 down here, so those aren't common. I have an x in all of my terms, and I have a y in all of my terms. So I can factor out 2xy. What I'm left with is 2 times 2 is 4xy squared. We have a minus that's left, 2x, and we have a 3. Okay. And again, you can check your work by using the distributive property and distributing these monomials to each of the terms, and you'll get what you started with. All right, letters D, E, and F, try them on your own, and then come back and check the answers. So, for negative 6x to the fourth, I have a negative 2, a 3, and 1, 2, 3, 4 x's. In negative 18x cubed, I have a negative 2, a 3, and a 3, and 1, 2, 3 x's. Negative 12x squared, I have a negative 2, a 3, a 2, and 2 x's. Now you might be looking at that and say, hey, you know what, Mr. Boland? There's a negative 6 factor in each of those, and that is also something that you can do. And as you get better at it, you'll be able to recognize. So I have a negative 2 and a 3 that's common in all three terms. That's that negative 6 that we can divide everything by. And I have 2 x's that are common in all three terms. So I have a negative 6x squared. What's left? Well, my first term just has the 2 x's, so that's x squared. My second term has plus 3x. My third term only has 2 remaining. Okay. Letter E. 9 can break up into 3 times 3. 1, 2, 3, 4, 5, 6 x's. 15 is 3 times 5 and 4 x's. 12 is going to be 3 times 4 and 2 x's. So my overlapping factors, I have a 3 in all three terms. I have 1x, 2 x's in all three terms. So we take out the 3x squared. What are we left with? We have a 3 with 4 x's, so that's 3x to the 4th. Plus we have a 5 and 2 x's. And lastly, we have a 4. Okay. Letter F, the first thing we've got a negative 3 and 3 y's. Second term, we have a negative 3, a 2, and 2 y's. Third term, we have a negative 3, a 3, and a y. So again, we look and see, well, I've got a negative 3 for all three terms, and I have a y in all three terms. So I take out negative 3y. I'm left with y squared plus 2y plus 3. Okay. All right, moving on to problem number 4. We have factoring a polynomial model. So now we're using this to represent a real-world scenario. And I'll tell you, on your quiz and on the test, there are problems that are like these. So write an expression in factored form that describes the shaded area of the following square using the given dimensions. So we're told it's a square, so we know that it's 3r and 3r. So area of the square, and I'll say a of SQ minus the area of the circle is going to be what we want to do. So what's the area of the square? Well, it's 3r times 3r, which is 9r squared, minus the area of a circle is pi r squared, and our radius is r. So that's pi r squared. Now remember, the directions said in factored form, so it means I need to pull out any common factors that I have, and I notice that this is a common factor, so they both have an r squared, and what we're left with is 9 minus pi. And you can just leave it as that, 9 minus pi. You don't need to use a decimal approximation there. It's actually more accurate to just leave it as the pi symbol. All right, so letter B, we have a circular mirror is surrounded by a square metal frame. The radius of the mirror is 5x, and the frame length is 15x. what is an expression for the area of the frame? So let's just draw a picture. We've got a square frame, and we've got a circular mirror inside. My radius of the mirror, we said, was 5x, and it's a square frame with a side length of 15x. So again, it's going to be the area of the square minus area of the circle. So area of the square is 225x squared, right? Because it's 15x times 15x. Okay, and we are going to subtract the area of the circle, which is pi times the radius, 5x squared. So that's 225x squared minus 25 pi x squared. So now let's look and see what are my common factors that I can pull out. Well, both terms have an x squared, and, well, 25 and 225. I feel like if I divided by 25, that could work. And I'm going to do that. I'm going to take out a 25, and I'm left with 9 minus pi again. So it's 25x squared, 9 minus pi. So if we were to do what we did before with our factoring, 225, instead of putting that in as 225 and x squared, I'm going to just break these factors apart. So 15 would be 3 times 5 times 3 times 5 x. That would be 15x times 15x. My second term has pi 5x 5x. Well, what's my common? I have a 5, and an x. 5 times 5 is 25. Sorry, there are two x's here. Oops. Oh, that's what it is. The x's are kind of diagonal of each other. That's why I got screwed up. So we've got 5 times 5, 25, 1x, 2x, x squared. What am I left with? 3 times 3 is 9, and pi. Okay? All right. Last problem, letter C. You're painting an accent wall shown below that has a doorway. What is an expression for the area that you need to cover with paint? So the area of my rectangle is what's being painted, and this doorway is not going to be painted. So I need to find the area of the big rectangle minus the small rectangle. So we have 15 times 6w minus 3w times w. Well, if I think about this, I can break 15 into 3 and 5. So if I do it that way, I have a 3 in both terms, and I have a w in both terms. So I pull that 3w out. What am I left with? 5 times 6, which is 30, minus, what's left over here? W. So 3w times 30 minus w would be the factored form of that area. Okay? All right. That is it for our notes for today. Make sure you fill in your level of understanding. Make sure you are being accurate. Write down any questions you may have come up with during this lesson, and make sure you write a summary of what we are doing. So what you should be looking to do is try to explain to someone who doesn't know what factoring is what to do to factor. All right? That's all for today. We'll see you in class.